Okay, let's talk about coding this thing. Right now, as it sits, it really doesn't do anything. It's connected up just like we did in the last video. We have our data line out from pin 12, going to the potentiometer, and then out to the piezo speaker right here. And then the circuit ends over here in the ground pin. So now we need to throw some code into this Arduino to make it do what we want. If you go up here to the code button and click on it, you'll see that this tab comes out from the right, and it already has some stuff in it. You can code in two different ways in tinkerCAD. You can do block code, kind of like Scratch, for other applications that I am actually not that familiar with, so I'm not going to show you how to do that. The block code, it's a visual way to code up things like this, and it's pretty helpful when you are learning how to code, which some of you are, but I'm going to skip it for now and go right to text code right here. It's going to ask you if you're sure you want to do that, and we are. If you see this right now, there's some code that's been put in here automatically. It is a default program that's preloaded on essentially every Arduino as soon as you take it out of the box. And it's called Blink, and it blinks this little light over here. It's an LED built into the Arduino. So if we click Start Simulation, you'll see over here that this little light starts blinking on and off. And we can analyze the code to show what is happening. The code has two sections already, one that's called void setup and one that is called void loop. These are functions. Void setup, or just setup, is the function that runs as soon as you plug your Arduino in. This is a bunch of code that runs one time. Whatever we put into the setup function will run once, and then it'll move on. The Arduino will automatically move on to the next function, which is loop. And those of you with any coding experience at all knows that loop means it's going to run over and over again. It's just going to run through this bit of code and then go right back to the top and go through it again and then through it again forever, as long as the Arduino is plugged in. Right now, the setup code is a function called pin mode. Pin mode turns on a pin to be able to be used at some point later on. This just says to the Arduino, hey, I'm going to use pin 13 as an output pin for now on, for the rest of this application. So if you want to use any of these pins down here at some point, you have to turn it on. Otherwise, the Arduino is just going to ignore them. The first argument in this function for pin mode is the pin number. In this case, is 13 right here. You might say, but hey, there's nothing plugged into 13. Why is it controlling that light? And just out of the box, the default is pin 13 is connected to this LED right here within the circuit. That's not all that important. The other option here is called output. This other argument, rather. Output means that you're going to be sending data out of that pin instead of receiving data. You can make this an output, or you can make them an input, and it just determines what the Arduino is going to use that pin for. Every single line of code, much like in C++ and JavaScript, I believe, each line ends with a semicolon. So if whenever you get errors here in the future, typically, especially for new programmers, it's going to be because you forgot to put a semicolon at the end of a line. down here in the void loop, there is a digital write function, which means we're going to write some information to the pin, in this case pin 13, which is the one they turned on here. And digital just means it's going to be either a positive or negative, on or off, 1 or 0 sort of information. And from pin 13, we're going to make it high. So we're going to take pin 13 and we're going to turn it on. We're going to apply positive voltage. That's all digital write does. This whole function just says, take this pin and turn it on. The next bit of code is a delay. This is a function that just kind of pauses the whole Arduino. It cannot do any functions or any commands or run any code during a delay. It sort of freezes it up for a moment. This argument here in the delay function is time. And it's not 1,000 minutes or even 1,000 seconds. The amount of time within the delay is actually in milliseconds, which tells you right here it's in milliseconds. So 1,000 milliseconds is 1 second. After that, we're going to digital write one more time back to pin 13, and low actually turns it off. So we are now going to take pin 13 and apply no voltage, which is the 0 or the null voltage. And then we're going to delay for another 1 second. So that's what the blink function does, the blink code. And you can see that what it's doing is turning it on, waiting a second, turning it off, waiting another second before it turns back around and turns it back on, waits a second, turns it off, waits a second. And you can see that that's what's happening right here on the actual Arduino. Novice coders will wonder what in the world this is right here. This is called a comment. These two slashes next to each other mean that whatever you're going to type in after this, those two slashes will never be coded. They are a comment for you to help translate what is happening in the code. It is a good idea to put in comments throughout your code so that when you take a break and go back, especially when you're new at this, you can figure out what in the world you are doing, because this is in turn a new language for you. You've never, ever, some of you have never coded before, and most of you have not coded in Arduino before. So making little notes about what you were doing at that moment is a good idea. So we're going to change this code up a little bit. We're going to change our pin. We're going to stop the simulation. That's a good idea. We're going to change this pin to pin 12 because that's the one we're working on right here. And it's going to be an output, so we can keep that there. But the rest of this, we can just get rid of. We don't want any of it for now. I'm going to just delete it, add a couple of spaces in here. You can put as many lines in this as you want, unlike other programming languages, which would keep you from doing that. And we need to utilize a feature of the Arduino, which is creating a tone. We are going to make this play a song eventually. And so right now we need to have this pin produce essentially a digital frequency through it. Maybe it's an analog frequency, so that it can vibrate this speaker. And we're going to do that with a couple commands here, a couple functions. The function to produce a sound is called tone. Seems pretty simple, and it takes 2 arguments. Those 2 arguments are what pin should we put the tone through, which is 12, and then we need to program what frequency we want that tone to be produced. And we're going to just choose a random number, which is 500, which is in the audible range. So right now, what this is going to do is, I'm going to put in a comment here, produces a tone through pin 12 at 500 hertz. After that, let's make it go for a certain period of time. So we're going to make a delay of another, let's say, 1500 milliseconds, which is a second and a half. And then we actually have to turn the pin off. Just like we did before with the blank code, we need to make this pin stop making this noise, which is a different function. You can't just do tone 12 and then 0 for frequency, which would make sense. But we actually have to go through and turn off the oscillator that is actually making this frequency so it stops doing anything at all. So we're going to use a function called no tone, which seems wholly uncreative. And then we just have to put in that pin like that, pin 12. Turns off the tone. And then we need to delay one more time. We can delay just so that it turns off for an appreciable amount of time. Here, delay for 1 sec. And then we can try this out. So to recap, we have this pin mode, turns on that pin, makes a tone of 500 hertz out of pin 12, and then the delay for a second and a half turns the pin off and then delays for a second. So this should play and it's essentially beep at us here in just a moment. So now I'm going to click Start Simulation and let's see if we hear anything. It initializes, and there we go. What a pleasant noise. And we can turn the volume up. Actually, bring it down. How fun is that? So this is maximum volume here. Then we can move this potentiometer around to change the volume. Cool. And we can click Stop Simulation, and it stops making that horrible noise. You could change this to a different tone. Let's say 750. 750. Then start the simulation again, and this will be a higher pitched tone. Cool. You could do this again. You could just copy this whole text here, do it over here, do a 550 and then a 750 tone, and so now it'll go beep boop, or actually boop beep. Running this code, running this code, running this code, running this code. And that's how you get this Arduino to start making noises. If you have this live in an actual hardware, you could annoy all of your family, which would be delightful. Next up, we will learn how to code. We'll do this some more and start making this into a song.